Hello everyone, welcome to this week's Twitch stream. Only one viewer yet, so I'm kind of like rambling a little bit then until everybody shows up. So chat works. Okay, so this time we have kind of a mixed task. What our plans are. In last week's stream, we kind of like tried to integrate the enhanced datagram logger that Adam worked on recently into the GRiSP board, but it crashes. Let me show you. So that's where we kind of left off. Let me get this table camera correct. This tripod is really bad. Should actually use another one. So GRiSP board, motor. So the general plan is to eventually work on the solar heating controller. I have some windows like going into there. Okay, on the solar heating controller, but we want to see the error messages because it's in another room. So for that, we actually started the logger, which got a much larger project than expected. And today, actually, where's this other window? So that's the solar heating controller. Oh yeah, this worked, okay. And when or if we kind of like figure this out, I have a clear idea why this crashes. We can then get started improving the solar heating controller. So there's a few logic fixes we can try and see if the logger works there, and watch it crash or whatever. But the little motor here is a hint, because to actually properly control our solar heating system, we want to control the flow of the water. So we want to do a control loop which controls the pump power. And to be able to do this, we kind of like need to be able to run on like half power, like 3/4 of power. And the way this is done is implementing, like the easiest way this is done is implementing pulse width modulation, which means that you switch the I/O that the motor is connected to on and off very quickly. And actually the pumps are connected via solid state relays, so this is actually possible, because don't do this with a real relay. You will just make a lot of noise and break your relay. But the solid state relays are kind of like, with them it's possible to do pulse width modulation with like mains power motors, like these pumps. Which means what they actually do is they wait until the sine wave goes through 0 and only then switch. So we probably should like do a multiple of 50 Hertz, and then we can optimize this. To get there, we need an improved GPIO driver, and we can actually try this with the H-bridge 5 motor and this motor here, like a DC motor. That's the motor that we also have in the shop to drive like simple kits like robots or whatever. Also, we Toynes and Adam recently did a tutorial in Berlin at Cold Beam Light, and that was, I think, as I heard, it was big fun. And I also saw the video they made. We have a new robot car for tutorials like this. Maybe probably kind of like describe how the kit is built eventually. And for driving robots, it's also good if you can actually do pulse width modulation and drive the motor slower, because usually these like they're much too fast and much too jerky if you do them on-off way. So let's look at our task for today. So We configured the datagram logger last time. Let me look at the configuration. Let's get rid of this aquamarine XNO. So that's the Emacs we worked on. So let me see. We actually did a config file and we configured the handler, and that kind of worked. So it actually made a difference because we got this nice crash here. So actually on the console we see logger callback crashed. So logger callback crashed, and we get a exit no process. So the process doesn't exist. And then kind of like for some reason I don't really understand, our I/O gets garbled, probably because there's other I/O at the same time. Happens sometime. But we were able to figure out that basically it's missing the gen server. So this looks like gen server, and the only gen server we have in the logger is, so let me get to checkouts. No, which, oh, we don't have checkouts. So we just configured it and it's in build. So we probably need to have the logger and checkouts to make this really work. So then we go to our log test. I think it's log test. So what's our, nah, not this, just Twitch. Oh, still. So we have the datagram log, we worked there. In log test, we actually worked on it. And probably in checkouts, we have hopefully the right version. So let me make sure that I pull the right version. No, I don't want to install something new. So that's the solar heating controller. We added the datagram logger. So that's our changes from last time. That's the config file that we are not. And we are adding this config. So this all worked quite, and we updated this. That was kind of like costing us a lot of time. So that's actually the wrong repo. Open. Log test, checkouts, datagram logger open. So let's see if we can pull something. Nope, we are on branch master. So this is the latest and greatest, I hope. So there was this separate proc. Adam kind of like factored this out into a separate gen server. And the idea was that this gen server is started with a supervisor. So this gen server is started here. So we need a process actually here because somebody needs to own the UDP socket we are using to send to InfluxDB. And since in a logger handler, we are basically not in some specific process because you're usually called in the context of another process. We need some place to actually have this UDP socket and a gen UDP, which is the one we are using, always needs to belong to a process. Maybe this is improvable with raw sockets, but we didn't try that out yet. And I think they're not stable enough, maybe they're still experimental. So we need a process, basically, which is this process, which gets started by a supervisor, which all it does is basically does a gen UDP open with 0, no configs, because we basically use, we basically specify the IP address every time. We open it. So this is every time we send, we specify the IP address, so we don't need to specify anything. It just opens a UDP socket. And we have this in socket, and it has a get socket call that is then basically returns the socket. So very, very, very simple gen server. And if you look in the, no, let's go into this directory. If you look in the actual logger handler, what is done here when a handler is added, there's basically, we call this process and called getSocket. And when we do this and the logger is configured in kernel, we get an error message that the gen server doesn't exist, which is clear because this is run when kernel is booting because it's in kernel config. So they actually wants to install the logger handler, which is also correct because we want to actually see the loggings from the supervisor messages when everything starts up. So at this point, the other supervisor, so the datagram logger supervisor is actually not started yet. So the process can't be there. And Adam didn't notice this because he added the handler manually, like on the shell. And then, of course, the supervisor is running. So this wouldn't work in this case. So what we actually need to do is we need to get rid of the supervisor and everything. We can actually spare this. And what we need to do here when adding a handler, we actually need to start the actual process. And to be honest, we actually don't need a whole gen server for this because we just need any process and also a process that's not supervisable. It's just a process that owns the socket. And we kill the process when the handler is removed. Basically, removing handler, we kill the process. So what we need is, so there is something, or actually, we actually add the data, so in the datagram logger, we actually have an add handler proc, so I didn't look at this, so what does this do? But the problem is the supervisor is not there, so that's the problem. Oh, that's interesting. There is no add handler proc here even. This is weird. So what do we do? Oh, datagram logger supervisor. Dgram logger supervisor. And there is an add handler proc, and that just does the start child, but that wouldn't work. We cannot use a supervisor here, basically. So instead of doing add handler proc, I remove this, we just spawn a process. Which spawn do we need? So we don't want to link to it because we don't have no idea in which process we are. So let me get the manual page. There's several versions of spawn, I think. So we don't want to have spawn link, but just spawn because we don't want to link. So this is probably a spawn function. No, we just have a function there. So we can actually, we probably should have a server function here. Or should we just put this in a fun? So we don't need arguments, but so what we do is from the proc we want to actually get the socket. And what we want to do is, there we need to be careful when we call self. So we want to actually kind of like need to get the information back to us. So we are in some project. So we get our own PID. And what we do is actually, let's call this parent. We basically send the result of GenUDP open to parent, which is the PID we are running from. And then we do a receive, stop, and then we terminate. And then we end the function. So probably don't need a separate function. It's actually more convenient like this. So basically we wait in a receive until we are ended. So that should, I think that should work. I mean, let's try this out. We can try this out in a shell. So what we do is just start a random shell, and then we run parent equals self. Oops, put a comma here. We need to put something behind. So parent is a PID now. And then we spawn something. Oh no, we want the PID also. We spawn this, so we try our call. I'm trying this out in the shell because if this crashes in the handler, it's kind of like harder to debug. So we would expect to actually get the message with the OK and the socket. So this seems to have worked. And now let's see. Okay. So we got a message OK, and then a port, which is the socket. So socket's kind of like a UDP socket is a port, which kind of like gets special commands. So this worked, and then we can look if the process exists. 083. Yeah, see, it's running in Erlang apply, receive. And so this is our PID. So we send to this PID stop, and that's the return. And then we see it's gone. There's no process 83 anymore. So just to make sure, oh, that always works, yeah. Sending your PID that doesn't exist. So this kind of like gives us convenience that this would work. So after we did this in our code, what we should do is actually get the socket, receive, okay, socket. We could actually put this. So we get a socket and we return the socket. So we don't want this here. Should we put a timeout here or not? I mean, this shouldn't be able to fail. I mean, whatever this before does, it should work. So yeah, that's our socket then. So that's how we get the socket, and removing handler, we send it. So we have the PID. Yeah, we've got the PID. And the PID is in our config. And removing handler should actually not use the supervisor, but just send stop to this PID. Now should we exit? No, it's simple enough. I mean, in theory, it could be hung, and then we have a leaky process. If we would be a supervisor, we would send it a terminate, and then if it doesn't terminate, we would actually exit. But yeah, I think it's good enough. Keep it simple. And then we kind of like, we don't have an app module anymore. So we did, so with Git we can just delete this. We don't need this anymore, and we don't want the supervisor. And in the app source, we actually don't want to have a mod because this should be a library application then. Okay. So let's see if this works. So first in the log test. So how do we do log testing? This is in we didn't configure this in log test. Are we feeling lucky and put it into the probably should copy the config from the GRiSP thing, from the solar heating controller. Gsol control, where did we put the config? It's in GRiSP files. Gsol control config. So that's how we kind of like configure this. So this would be okay because we are on this IP anyway, and we put it into measurements, so and we don't send the timestamp. Yeah, just copy this. So projects. Not many views today. What's going on? It's getting boring. Probably need to work on something else than logging libraries, but I'm pretty sure we have a 1.0 very soon here, and then I won't touch it for a while, or at least on the stream. So we probably need to find more funny things, or maybe we need to find another time in the week. So maybe Friday afternoon kind of like doesn't work for everyone. But then I know that lots of people like watch it, or at least I see that lots of people watch it offline. So now I confused myself. Where am I? We want to log test. See if it compiles. Looks good. Bar 3 shell. So it says it booted the datagram logger, but it didn't. And so there. Let's get the reference manual. How do we ask it if there is a logger installed? Get, what was it? Info notice. Get handler IDs. So doesn't look too bad. So the logger seems to the datagram logger and the default logger seems to be installed. That's good. So we just add it to it. And then how do we test the logging? I think we have some test code here. Let's check what we have. No source. Build, checkouts, apps, config. Oh, we have a log test app. Oh, but that doesn't do anything. I thought we had some. Well, actually, we don't care. We don't need any code. But I was assuming that we had some code here to see the line numbers or whatever. So we just call logger directly. So logger info. Hey. It did something. No idea if it did the right thing. We have some window where we have our InfluxDB because that's where we would expect something. Didn't see anything. So what did we configure actually? What did we configure? So where does it actually get the database? Oh, we configured the UDP database thingy. So it always goes into this database. So we need to kind of like lost my window where we query InfluxDB. Oh, my InfluxDB got rusty. So InfluxDB, yeah, consent manager. Where's the documentation? I always hide this somewhere. Influx data. No, I don't want InfluxDB cloud. Developers, I think. Get started. Well, let's go to get started. Download sandbox integrations, dashboards, documentation. Yo. So influx command. So let's just copy this. Does this work? Connected. InfluxDB shell versions. Looks good. Let's make this a little bit larger. Yep, there's our InfluxDB. So we can actually say use gsol control and exploring. No, we don't want to. So select, what fields do we actually use? Now we need to look into the logger. Didn't do this long enough. Datagram logger. So what kind of fields would we expect? For example, our level. No, that wasn't it. So what's the measurements we are sending? I had so many examples here, but I kind of like, select star from so. That was a mistake. Now we're getting everything. Oops. So yeah, that's a lot of content here. Oh, it's still alive. So select so the measurement we are using is sol, and we are this code got refactored a bit. Maybe select message from sol. Yes. But this is not from today. Oops, sorry. So maybe info is filtered, so we do error. We have a hey here, but this is ages ago. October 18th. So it works. And then let's see. Oh yeah, now we got something. So info gets filtered, only error gets shown. So this works. That's pretty cool. So we can actually commit it and put it on the GRiSP board and see if it works too. And then we can actually show it in the graph, and then we are finally there where we wanted to be, like, I don't know how many sessions ago. Okay, so let's commit this. So what did we do? Let's get rid of all this garbage. So that's the datagram logger. So this is deleted. Yeah, we don't need it anymore. This is the simple process thing. We're not starting anything anymore. So this is all good. So we stage all and remove supervisor. Only works when the handler is added from the shell, but it's not ready when configured. Oh, that's the 80 characters thing. When configured. For kernel. Okay, commit, and then we push. Okay, and oops. So we have a build terminal. Look at me. Let me get this terminal. This one? Yes. So now I need to be careful. Oh, there is no. Yeah, we didn't do anything. We got a new GRiSP. And let's see if we can get a yep, it changed. See here, this version, and here that version. So that worked. Yeah, we can deploy it right away. So that's our test GRiSP board. So we put the SD card. So once this works on this GRiSP board, we can put it on the solar heating controller. Well, actually, we probably don't, yeah, we don't care. So what we probably want to do is, I mean, we can use different measurements, and we probably should not put this into measurement so, but into measurement logger, because then we have everything separate and not mixed up. Yeah, so we redeploy. Okay, so that's complete. So what we do is we put it into the GRiSP board and look at the terminal now and boot. And now we're expecting that we have no crashes anymore. So yeah, it's booting, 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 booting. This one. Nothing in logger. Oh, something happened. Hmm. Hmm. Oh, but that's okay. Cause, why is this okay? Um, Actually, our logger kind of like worked. And we're now getting complaints that the one-wire driver is not seeing their sensors. So that's actually crashes we would expect to work. And let's see if we see, oh, very nice. Except it doesn't look really nice. So why can't I scroll here? I think we need to kind of like shrink the font, make this larger. So the formatting is not nice yet, apparently. But we get our log stuff. So that's the first time that we actually get logs, working logs, through our logger handler into InfluxDB from this GRiSP board on the table. So that's good. The question is, why do we get this like numbers here in file? So that's probably some formatting problem still. So why is that? So we get, so what would be the message? Select device, and then somehow we don't get a string here. This worked in the past, I think. So select device. So it's actually, so what we are not seeing is this string. It's the file. Okay, so but that's details. And that's probably details we will deal with later. Because this is like a major breakthrough that we kind of like get from the GRiSP board, logger data, right from the booting. So we probably got, so there's more stuff, progress reports, I hope. So where's the progress reports from the beginning? That's kind of like the first thing. So we only get the initial call, simple control in it, and then we kind of like get this list of numbers instead of a string, which means, so that's probably into the corner that, because let's see if we can find something simple. Datagram logger. So what we're getting here is we're getting send config maps get measurement IOLib format level tags space fields format timestamp blanks, and so format text and format fields are the functions we're actually doing this. So here is special treatment of SUSL logs, report values, label report. So the values kind of almost worked. Islist, smap, format entry. So we have to look at format entry. And format entry key value. Or if there is no key, we kind of like have a dummy key, which is not nice. But we have when is integer, is boolean. Now that's kind of weird because format entry should actually format this correctly. Unless, oh yeah, that's the, there's a special thing that this is basically, if you look at this, then the reason you get basically here is you get this tuple, nothing present, and then you get the select device, and the problem is that this is a list. It's a list in the list, so we get a list of lists. So this kind of like needs to be flattened. Well, as a matter of fact, so we are missing here not only a special treatment of SUSL logs, but for SUSL logs we probably need to flatten the report, or at least like see what kind of like reports we can get. So this is, I think this is still an open issue. Um, No, not, yeah, that's okay. Yeah, that's the crash time problem. So this is still the open issue that needs to be done. Um, so reason is that our report formatting thing expects um, a key value list, but this is a list which has one key value, the proclip crash, and then we have a nested list of the stack trace. So we need to kind of like make a special formatter for this, or fake it somehow, I don't know. And then actually our strings would be visible also, because now we just get this one value. So that's the one value. We get here gen server error info, terminate measure. Yeah, so that's this thing that needs to be nicer formatted with key value, whatever. Um, but in general, we need to think about like what do we want to do with a crash dump. We probably want to have like a crash dump value, and then maybe have it like somehow nicely formatted. Maybe we can find some formatting code and just format the whole crash dump as a string. So that would be probably a solution, like format this as a string. Um, like basically format it in the same way it's formatted here, so that we would have this as a string um, in the log, because I don't see that having these key values here, the whole crash dump thing, um, like as keywords and values, because it's a crash dump. I mean, it's arbitrary length, so you cannot have like, yeah, this is like a log level or whatever. Okay, so this is a little bit more work, but we kind of like can put it on a GRiSP board and we can see our crash dumps, even they're not looking nicely. So, Ttref showed up. Good morning, Ttref. Catch up login. Yeah, Kickstarter GRiSP 2 development status, we are delayed. Um, I was like waiting for the hardware developers to. So basically, we're delayed anyway because the hardware design was delayed, and then we figured out that that at our default hardware manufacturer, the prices went up, and we cannot actually keep the price tag. So we were looking for new manufacturers, and we found a manufacturer which lets us keep the price tag, but they have much longer delivery dates. So I don't want to tell something. So it will be sometimes in 2020, unfortunately. So no boards in October. Otherwise, I would have like shown you the sample boards. So we just ordered the samples, which will take 6 weeks, and then the hardware devs need to get it done. So we expect to have the first samples in our hands and also in the hands of the NERVS people in January. And then we need to validate the hardware. So we need some time with the hardware. So I hope we have enough time in January to actually validate the hardware. And then, unfortunately, the making of the first batch will take 12 to 14 weeks. And otherwise, we would have like need to increase the price for 40 euros. And since basically this is only initial delay, because the longer delay for further batches, we can manage this by just ordering them in time before we run out of boards. So yeah, so that was a short rundown. There will be a Kickstarter update over the weekend. I just didn't get to it, writing it down and showing the nice timeline. Um, Unfortunately, it's delayed, but fortunately, everything it's not delayed for some horrible technical things. It's just delayed because we couldn't find a manufacturer. Because apparently, even while the economy is kind of like cooling down worldwide, German manufacturers of PCBs are still very busy, which lets them get their prices up. Also the other good news is we are still manufacturing in Germany, so it will still have the made in Germany label on it. We just needed to go to a PCB maker with a different basically business model. So yeah, but it's in the works now. So the hardware design is finished, and the first samples are being made as we speak. Okay, so thank you for watching, or thank you for catching up later. I don't know what we will do next week. Maybe next week we will actually work on this motor thing and like this motor thing and pulse width modulation. Yeah, real world bytes. Yeah, tech content is unchanged. No troubles there. So yeah, thanks for watching. See you next week. So today we only had one live viewer. Maybe we want to look at a different time slot, but I kind of like need to figure out how to ask everybody and see where the best time slot would be. Yeah. Okay, so talk to you next week. Bye.